G'day and welcome to this special episode of Mr. Code's Python Robotics, where we're going to learn how to get started programming in Python for the LEGO Spike Prime. Hello, my name is Gary and I have been a video game developer for over 12 years. You may be wondering why Python is such a popular programming language. Well, the reason is because Python is supported by a really diverse ecosystem of tools that allow programmers to make anything from simple scripts for home automation all the way up to machine learning, big data, apps, video games, and so forth. As an added bonus, Python is relatively easy to learn, making it the language of choice for most beginner programmers, which brings us to this, the LEGO Spike Prime. The sponsor of today's video is More Educational, who have kindly provided this LEGO Spike Prime kit. More about them later in this video. LEGO has a long and proud tradition in robotics education, but this latest version is an absolute beast when it comes to programming education. You can learn with block-based coding, and when you're ready, you can also move on to your first typing-based code using Python. You can see all of my previous Python robotics tutorials over here. But as with all software, there have been many features and improvements to the software that I think deserve a new beginner's video. I spend a lot of time making coding tutorials just like these, so if they help you out in any way, then please consider liking and subscribing to my channel. It is your support that lets me continue to make coding videos, so I thank you in advance. All you need to get started is to download the LEGO Education Spike Prime app and to get yourself this LEGO Education Spike Prime Hub. We are also going to be using the electronic parts like the motors and sensors throughout today's tutorial, and you don't need to build anything. All you need is the hub and all the wired components. To get started, let's look at our Spike app. So here at the start, you just press on the Spike Prime solution, and then it's going to ask if you have everything in place. So here we're going to start a new project and make sure it is a Python project. We're going to get started with our introduction. So here we're going to call it My First Python Project. Hit create. So here on the top half of the screen is your coding area. You'll see that there's already some code in place. Now, at the start, we have all of our imports. Because Python is a coding language, any kind of technology can use Python for their solutions. So Python does not inherently know how to operate with the LEGO Education product. So what it does at the start here is to import all the classes and all the libraries to teach Python how to operate the different components for the LEGO system. So here from Spike import Prime Hub, Light Matrix, Button, Status Light, Force Sensor, what all this does is to teach Python how to operate these bits of hardware. We also have these helper functionalities from Spike Control, where we import the waiting blocks, the timer blocks, and then also in math. This is from Python. So from the native Python code, we're also importing our math libraries. Over here, we have hub equals prime hub. This is called an object, and hub is basically the name that we have given our robot at the start, this actual hub over here. And it's equals prime hub because prime hub is one of these Spike library items that we have imported. And then finally, at the end here, hub.lightmatrix.showImageHappy. What this does is it shows a happy face on our actual Spike hub here when we run the code. So let's get started by simply getting this code running on our hub, shall we? What we need to do is we need to turn on our hub. So here is my hub. I'm going to press the middle button to power it up. Excellent. So now that it's powered up, we're going to have to connect it to your computer. Now you can connect it in two ways. You can connect it either with a USB cable. You can have a white USB cable and plug it into the top of your hub, and then plug the other side into your computer, or you can plug it in wirelessly, connect it to it wirelessly by pressing this Bluetooth button on the top corner of this hub. So let's press that, and it's going to start flashing blue. All right, back in our Spike software, we're going to hit this connect button on the top left, and then we're going to wait until it locates our hub over here on the side here. Okay, CA500, that's the name of my hub. I'll press connect. All done, too easy. If it asks for a hub update, then you hit the hub update, just like how mine has appeared over here, and then you just wait a few moments for it to fully install the update. Alright, hub update seems to have finished. Hit the done button, and then we're going to try and reconnect it. So here we hit connect again. Alright, fantastic. Give our hub a unique name. Just call it CA500, which is the name of my hub. Alright, so we are now getting ready to roll. So in our software, we are going to press the play button that is just behind my my chest at the moment. It's right over here. This yellow this yellow button. All right. So what we want to do is press that yellow button, and then it should show a happy face on our hub. Okay. So press the yellow button. I haven't done any changes to the code. Now have a look at my table, and then see it shows a happy face. All right. Super simple. And now back in the software, we want to actually do something now. All right, we're going to have a look at our knowledge base on the side here. So the knowledge base is by default starts open, but you can close the knowledge base by pressing this little handle over here. But here in this knowledge base, you can learn pretty much everything about working with the Lego components using Python. For example, you go into color sensor, you'll be able to see all the different methods for the color sensor. You'll be able to see all the different events, and also you'll be able to see code samples. So if I click on wait until color, then you'll see down the bottom here there are some code samples here as well. So if you ever get stuck, you can always open up the knowledge base to find out how to do something. All right. Okay, so it's great that we can do this show image, but now we are going to try to do something else. We're going to type out a message in this console over here to print out the message, hello world. Most programmers, when you do your very first program, is a hello world program, just to test to make sure that it is all working. So we go print hello world. All right, hit the play button, and then you'll notice that first thing we do is we show this happy face, right? So on our table we still have our happy face showing, but also on our software we now have hello world being printed on the console. Now this leads us to the final part of our software down the bottom here. This console is very helpful for Python programmers. It lets you add messages here, like the way that we have printed out a message hello world, but also it tells you if there are errors in your code. Now errors in Python are just things that we have to deal with. When you are coding in Python, sometimes you might mistype something, or you might forget a symbol, and then you might have an error. And the errors will all be printed out on this console as well. Okay, so now that we know how to access the console, we can move on to the next thing, because typing hello world out in the console is fine, but it's cooler if we can put hello world on our hub. Here we're going to do something called a comment. Alright, so a comment is where you go to the start of your code, and then you go and put a hash symbol in front of it. Okay, at the start of a line of code, you put a hash symbol, and this creates a comment. Okay, so a comment is to tell Python to ignore that line of code. Okay, and you can see that it's ignoring the line of code when you see it turn green like that. Okay, when we are ignoring that line of code, you can use it to type in messages and notes about your code to remind you or remind your team members about what this code is doing. Or, just like how I am doing it right now, I had some working code, but I don't want to run it this time, so I've commented it out. Okay, that's why I put a hash symbol there. What I want to do instead is I want to go hub.lightMatrix.write hello world. Okay, oops, hello world. Now, instead of showing a happy face on my hub, now it's going to write the message hello world on my hub. Okay, let's hit the play button and have a quick look. See? So now we are writing messages onto our hub using the light matrix as well. And if you look back in your code, you'll see that our console continues writing messages. So here we printed hello world once when we were running the code before, and it printed it again when it's running for the second time. Next, we're going to learn about objects. So objects are like these little bits here on line 5. That's a hub equals prime hub. Now, the left part of our object, this is an object. You can type these out, these notes out if you like. This will hopefully improve your understanding of the code. This is an object. The left part of the object is the object name, and then we have an equal sign, which to represent we're assigning that object name a type, and then we say prime hub. That means that hub is essentially a clone of the prime hub object type. Okay, but we're going to do something different. We're going to add some data here. Okay, how about we'll say message equals hello world. Okay, what this does is it creates a object with the name called message, and then it equals hello world in quotation marks. This means that we are creating a text string. Okay, so we are creating a text string called message, and that message is hello world. Okay, so now instead of having to type hello world in line 8 and 9, we can simply replace it with our message object. So here we'll just put in message and message over here. Right? So here when we press play again, the code is going to run so that it types out hello world on our app first, on our hub first, and then followed by hello world afterwards. Okay? Because we are running the code line by line. In Python, it is a procedural programming language, which means all the code happens one line at a time. Okay, so it runs line 8 where it says hub.lightMatrix.write message. So it writes the entire message first, and then it prints the message inside the console. Now, when you have more and more code being written, it's important to realize the importance of keeping your code organized. Right? Always have your imports up the top, followed by your objects, followed by what we are executing afterwards. It has to be defined in that convention to make it so that your code has the best chance of success. It doesn't have to read things out of order. Okay, if you swap the orders around, it may still work, but it can also cause problems down the track. Okay, let's continue. So we now know how to write a message hello world, for example, and also we know how to write a message on our hub. But let's now do some more work on our objects. Here, our message equals hello world, but how about let's define some numbers. So x equals 5 and y equals 6. Okay? These are still objects, just like how we've created a message equals hello world, x equals 5 and y equals 6. These are different types of numbers. Okay, so x is equal to the number 5 and y equals to the number 6. So now we can potentially print out a message on our hub to demonstrate some simple maths. Okay, so let's say we'll write, instead of writing a message, we'll comment that out as well. We'll go hub.light matrix.write, and then we'll put in x. Okay, you see that I don't have a quotation marks, any quotation marks around my objects, because the object names don't have quotation marks. Only strings have quotation marks. Strings are the text, right? So here hello world has quotation mark because the object is message. We didn't have to put quotation marks around the message. All right, so now let's see if we can write the number 5, write x on our hub. Here we go, right in the number 5. Super easy. So now we are going to do something more interesting. Okay, we can now write x plus y. Okay, because x plus y should equal 11. So if I run this now, this is some simple maths, it should show that we are showing the number 11. Okay, very cool. I'm going to remove this print message for now, just so that we don't keep flooding out our console. But what else can we do with maths? Well, here are all of our maths symbols. Okay, so here we can go our maths symbols. Okay, plus, whoops, actually what I'm going to do is do something called a block comment. That means that I'm going to comment out a whole bunch of lines at the same time. That way I don't have to put a hashtag, the hash symbol, in front of every line. So it's 3 quotation marks in front and 3 quotation marks behind, and that creates a block comment. All right, so here is plus, this is minus, and then the time symbol is the asterisk. Okay, and then the / symbol is divide. Okay, and then we have a special math symbol called modulus that we're going to talk about later on. Okay, and that's using the % sign. So now we can play with our maths abilities. Yeah, so here, scroll back up to the top where we say hub.lineMatrix.write x plus y. We can now go x times y, and then we can see that we are now able to do our multiplication as well. See, comes up with the number 30. We can also divide. So here we can go divide x / y. You're going to notice something pretty interesting here. Whoops. It shows, I'm going to do it one more time. .83333, and it only shows the first few characters. Okay, so here back in our maths, let's just comment out our math stuff now, and let's look at how modulus works. So modulus works similar to divide, but instead of returning the answer, the quotient, we are returning the remainder. So if I go and say hub.lightMatrix.write, and then I say 10 modulus 3, then the answer will be 1, because the modulus symbol goes 10 divided by 3, and 3 goes into 10 3 times, and then there's one remainder, which is why it'll only be, the answer will be 1. Okay? And modulus is really useful for finding out if something is divisible by something, because all you have to do is make it so that you're checking to see if the modulus of a number is equal to 0. That means that that number is fully divisible in that number. The next thing we're going to learn about is loops. So let's comment out that last bit on modulus. And a loop is a way to repeat something in Python. Now there are two main types of loops, for loops and while loops. Let's talk about for loops. For loops are used to repeat something a fixed number of times. Okay, so here to write a for loop, you go for I in range, and then you put in the number of times you want to repeat something. So 10. Colon, and then when you press the enter button straight after the colon, you'll notice that my cursor has become indented. Okay, so to indent, all you have to do is press the tab key, but sometimes your code is going to automatically indent for you, which is really, really helpful. To indent means that everything that we put inside this indentation underneath the for loop is going to be repeated. Okay, so here we're going to go hub.lightMatrix.write I. What's that going to do? We're going to write the letter I, which is an object inside this for loop. Okay, this is an iterator. Okay, and it's going to start from 0, and then it's going to write 0, and then the iterator will increase. It will go, I will equal 0 at the start, then it will equal to 1, then 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is basically going to write the numbers from 0 to 9 on our hub in sequence. Okay, so this is a demonstration of that. Let's hit the play button and have a look. So it's going to start by writing, oh, it just went straight to 9, and the reason is because it wrote everything else really quickly. That's right, because Python on your Spike Prime hub writes things or iterates through 1,000 times a second, so it's very, very quick. So to slow it down so that we can see what's going on, we're going to say hub.lightMatrix.write I, but then we're going to go wait for seconds 1. That way we're going to wait for a second straight after writing each number. Okay, so let's try that again. 0, 1, 2. So this is how we know that our loop is working fine. Okay, all right, back into our code here. Now that we know how to write a for loop, we can repeat anything we want here. We can do all sorts of stuff. Whether if your robot is moving back and forward, and if you want to make it dance 10 times, you might put a sequence down here for the robot's movement, which we'll talk about later on in this lesson as well. Another thing we can do, instead of just writing things on the hub, is to access the hub's speaker. Alright, so the speaker code you can see over here inside the knowledge base. You scroll down to speaker, and then you'll be able to learn how to do the different speaker methods. But for now, all we have to learn is the beep method. Alright, so here, when we are repeating something for 10 times, let's make it so that instead of wait for seconds, we are going to beep for a second. So we'll go hub.light. Oh, whoops, not light matrix. Hub.speaker.beep. And then we're going to beep at a certain value. So here we got the note that comes at the start and then how long to beep for afterwards. So we'll go beep 60 0.2. Oh well, actually let's keep the wait for seconds here as well. So now it's going to say write the number on our hub, then it's going to beep, and then it's going to wait for a second for the next one. All right, super easy. Here back in the code, we can make all sorts of music by changing the tone in 60. So if you turn it lower, then the note will go lower, and if you increase it, it's going to make it a higher note. So you can feel free to try to make some music by putting a whole sequence of these notes in. And then the second number, separated by the comma, second number represents how long that note goes for. So 0.2 means 0.2 seconds. Now there is a second type of loop called a while loop. And whereas a for loop is for repeating something a fixed number of times, a while loop uses something called a condition to determine how many times you are repeating something. So in Scratch, you would use something like repeat until, or a repeat while. And in Python, a while loop is written something like this. So here we have the code that we had before. Let's comment out our for loop. And let's create a whole new section of code here. While loops are used to repeat something while a condition is true. So let's create z equals 0. So that's creating an object called z. Next, we're going to use the while keyword. So while z is less than 10, colon. So while z is less than 10, we are going to repeat whatever we put inside the code here, inside this indented line. So also hub.lineMatrix.write, and then we'll put in z. Hub.speaker.beep 60.2. Wait for seconds. 1. And then finally, we're going to increment z. So z equals z plus 1. And in Python, we have a shortcut for this. So we can just go z plus equals 1. Okay? And this is the same as z equals z plus 1. All right, let's break down this code. So first of all, we are setting the object z as a number equal to 0. And while z is less than 10, it's going to repeat the objects, the code underneath. Okay, so obviously z is equal to 0 at the start. So yes, z is less than 10. So the matrix will write the number z, which is 0, make a beep, wait for a second, and then it's going to increment z. So it's going to add 1 to z. So z turns into 1. Yeah, or 0 plus 1 equals 1. And then we do the same thing again. It's going to write the new number, which is 1, and then make a beep, and then wait for a second, and then it's going to add another number onto z. So it's going to equal to 2. And then it goes and repeats this whole loop over and over again until z is no longer less than 10. This is exactly the same as the functionality that we did before with the for loop. But instead of telling it explicitly that we are going to repeat a certain number of times. We're going to repeat while a condition is true. So it is functionally exactly the same. So the key part is this this condition over here, this less than symbol. So there are lots of different conditions that we can use in Python. And here are all the different kinds of conditions. So here are the conditions. So this is less than, more than, and equal to. So notice that equal to has two equal signs, not just one equal sign, because we already have a function for just one equal sign. Remember, up here with one equal sign, we just assign something to be equal to something. So to test a condition, we need to have two equal signs, so as not to confuse our Python code. More than or equal to, less than or equal to, and then we have not equal to. We can also combine different conditions, so we can use and or as well. So here are all of our different conditions. Let's play again with some of our conditions. Let's comment out our while loop up the top here. Let's go down here and create a little program. Okay, let's make an age checking program. And in Australia, you can drive when you are 16. Okay, we're going to check if you are old enough to drive. So here we go, age equals a number. So I'm going to put in 30. And then we're going to use a condition to check if we are allowed to drive. So if age is more than or equal to 16, hub.lightMatrix excuse me. Dot right, you can drive. Else hub.lightMatrix dot right, you are too young to drive. Okay, so if I run this code, remember I've set my age equal to 30, so if I press play, it's going to say you can drive. Okay, on the same token, if I go back to my age and I switch it so that I switch it to 10 years old, I hit play. You are too young to drive. Okay? Okay, so now that's how we can use conditions to do different kinds of checking. So while loops are also used to create forever loops in Python. Inside a Scratch program, you might always see a forever loop from your control blocks as part of your program. And in Python, we do the same thing by using a while true loop. Here is how that works. With Python, all you have to do is go while, and then instead of putting a condition in front of it, we just put true. Because when we have a condition, all we're doing is that we're testing whether it's true or not. When you put true in straight away, it's not going to ignore the condition altogether and then just keep on repeating whatever is underneath. And that's really useful for button presses on the hub as well. So here we'll say, while true, if hub dot left button dot is pressed, colon, hub dot speaker dot beep. Okay, so here we're going to test that out. So here the hub is running and there is a forever loop running in the background. Every time I press this left button, it's going to make a beep sound. See? Super easy. Back here, we want to make it so that we remind ourselves that this is how to detect button presses. The next thing is to access the gyro sensor that is built in to the Mindstorms or the Lego Spike hub. So inside the hub, there is an accelerometer that can detect your 3-axis of motion and also your acceleration in different directions. So when you look at your hub, there are 3 different angles. So here, this sideways angle, like this turn like this, is called the yaw angle. The up and down pitch like this is called the pitch angle. And then this sideways rocking motion is called the roll angle. Okay, so we're going to try and detect all 3 different axes of motion using our Spike Python code. Here, let's go and comment out our button press. Let's do another forever loop. So while true, we're going to print out the yaw, pitch, and roll angle on our console. So here, let's open up our console. And then we're just going to go print yaw, comma, and then we go hub dot motion sensor dot get your angle, open close brackets, and then it ends with a close bracket there. So if you ever forget how to access your motion sensor, you can always go into your knowledge base and then you go scroll down to your motion sensor, and then you'll see that there is your get your angle over here. You can click on that and then you can see the code examples over here. Okay, so if I press play, then I can actually just twist my hub around on the table, and then you'll see over here down on the console that the numbers are constantly changing. Okay, so I'm just tilting out my my hub around like this, and then you'll see that it is changing the value of the yaw angle on my console. Okay, now this is useful for doing things like accurate turns and navigation using your hub, using Python. Okay, just like if you were using Scratch, this is going to be really helpful. Okay, and at the same time, we can also print out our pitch and roll angles as well. So here, what we go is like this, comma, pitch, hub.motion dot, motion sensor. I'll just like this. hub.motion sensor dot get pitch angle and roll hub.motion sensor dot get roll angle. Okay, so if I press the play button, I can also get all the other angles as well. So now you can see that I am rotating my hub around in all sorts of different angles, and then on the bottom of the console you'll see all the different angles as I flip and roll my hub around. Next we're going to add a motor to our hub. So the motors are these ones over here. So you can use a medium motor like this, or you can use a large motor like this. Both are treated the same way in the code. Just attach it to, say, port A on your hub. Okay, so here I'm going to attach my medium motor to port A, like that. And then let's do some experiments with our code. Over here, we're going to comment out our while true loops. And let's do some single motor control. Okay, so first thing you have to do whenever you add a peripheral to your robot is to add a reference to it, add an object reference. So here we're going to call it motor 1, and that is going to equal a motor at port A. Okay, make sure that you have capital letters for your port letter. If you don't use a capital letter, you're going to get an error down here in the console. Motor 1 equals motor at port A, and now we're going to do all sorts of exercises. Okay, so if we go motor 1 dot start, all you're going to do is just start the motor running. We're not even going to stop it. So here I press play. It's just going to roll the motor. Okay, so the motor is not going to stop, it's just going to keep on running. Okay, very cool. Now if I want to make it so that this motor stops running after a moment, we can do something like this. So here is start the motor and keep running. Okay, we can do something like wait for seconds, wait for 2 seconds, and then we can go motor 1 dot stop. And this waits for 2 seconds. Okay, if I do that and press play, it's going to just run for 2 seconds. Okay, so that's really, really cool. But instead of using a wait command, we actually have a built-in function for our single motors. If you go into your knowledge base, you'll be able to look for your single motors down here under S, single motors. And then you'll see that there are a whole bunch of ways to move your motor. We've just seen start and stop. Okay, there's also start at power as well that changes the power of your motor. So here we can do something like this. Motor 1 dot start at power, and then you can make it 100 to make it 100 power, 100% of power, and then you can turn it up and down here as well. So here we'll go motor and motor power, and then when we press play, so you can see how the motor moved a lot more aggressively just then because we set the power right up. Okay. We can also add numbers to your motor start value as well. So if I comment out this line and go back to this motor start method, where we go motor.start open close brackets, if you look at start, there is also a speed here. So instead of starting it at a certain power, you can make it start at a certain speed. Okay, now speed and power are two different things. Okay, so speed is the how quickly the motor turns, and power is how much energy you're putting into the motor. Okay, so it's essentially the torque of the motor. So here we go, can put in 100 in our start value. You can press play, and then you can see this is the fastest way to move the motor. Okay. All right. Back over here, if I change back over here, we can also use different motor control methods like this. Motor 1 dot run for seconds 3. That's going to make it run for 3 seconds. And then if I go comma 50, that also changes the speed of my motor, or speed or power. Let's have a quick look. Run for seconds. Yeah, it's the speed. So if I go run for seconds 3, 50, and then I hit play. So the motor is going to run for 3 seconds at 50% power. And it is a lot more efficient to use this line of code instead of to just say start at a certain speed, say 50, and then have a second line that says to wait for 3 seconds, and then a third line to say to stop the motor. Okay, so this is all done by the one line. Okay, run for certain number of seconds. We can also, in the same thing, go like this. Motor 1 dot run for degrees 90, and remember the first number is the amount that we're rolling. Second number is the speed. So here we're going to roll for 90 degrees, which is just a quarter of a circle at 100% speed. See? Very, very quick. Over here, we can also run for rotations, okay? Whoops. Don't need to comment it out yet. And running for rotations is exactly the same as running for degrees, but instead of counting all the degrees, one rotation is 360 degrees. So here we're going to run for 2 whole rotations of the motor at 80% speed. All right. Finally, for really, really accurate movements, we're going to have a look at run to position. So here we're going to go motor 1 dot run to position, and let's make it go back to the 0 point. But for run to position, there's also a clockwise and anti-clockwise direction. So here in direction, we can check for shortest path. we can also go clockwise or anti-clockwise. So clockwise or counterclockwise with a capital. Okay, so let's have a try. Shortest path, 100. So here I'm going to check my motor. So here is my my angle. I'm going to move it to the side here. So we're going to try and just move it to the 0 position. So when I press play, all right, that runs to the 0 position. But also we can change it to make it go counterclockwise or clockwise as well. So here we can go shortest path, clockwise, and I'll hit the play button. All right, so the motor moved in the clockwise position to get our motor into the 0 position. We can also move it to the anti-clockwise position. So here, so we go counterclockwise. Okay, so run to position, just like in your scratch blocks, can be using the shortest path or to go in the clockwise or counterclockwise position. You can also change the speed at which you go to that position as well with that third parameter. All right, so the next thing we're going to learn about is this distance sensor. Now, this distance sensor in LEGO Spike Prime is exactly the same as the ultrasonic sensor in the EV3. Basically, there is a sender and a receiver on this sensor that detects the ultrasound that goes out and back into the sensor, so it detects the distance between the next closest object. Very, very useful for different things like competitions and robots that need to be aware of their surroundings. So let's get to coding this distance sensor. Go back to your code. We're going to comment out our last motor control code. And of course, as you are following this this tutorial, it is best to just type out all the code that I'm writing. Now, at the end of the lesson, I will also give you the link of the code so that you can just download it. But it's always best practice to just practice your typing so that you reduce the amount of errors that you get in the future. So this one is run to the right position. Okay, let's go for our distance sensor. So just like with our motor, where we had to define our motor port, we have to do the same thing with our distance sensor. Okay, so here we're going to plug in our distance sensor to port B. Okay, so here we're going to plug it into port B, just like that. So here we have a distance sensor now at port B. And here we're going to say distance sensor. That's the name I'm giving to my distance sensor. Just distance sensor equals distance sensor at port B. Now remember where distance sensor comes from. I have to spell it this way because right at the top, remember when we were doing our imports, we were doing all our imports up the top here, and here's distance sensor, okay? So distance sensor needs to be spelt the exact same way as it was imported, but the name doesn't have to be the same. Like distance sensor over here, I can call it sensor if I wanted to, all right? But I'm just gonna call it distance sensor, all in lowercase with underscores in between. That is the convention for Python objects. That's how we're going to call it, just so that we don't get muddled up. All right, let's have a look. Okay, everything else is commented out, which is great, because now what I'm going to do is just test out the distance sensor, make sure that it is working. Now we can easily test out the distance sensor by looking up on the top here where we have our peripherals. As you can see, the numbers on the top where my cursor is changing depending on where I'm moving my distance sensor. If I scan it close to the table, it is pointing at 8 centimeters, 10, 15 centimeters, and when I point it into the air, it reaches the max at 200 centimeters. So by just looking at this, I can tell that the distance sensor is working. But if I want to access the distance sensor with code, then this is what I do. I'll go print distance sensor dot get underscore distance underscore cm for centimeters, open and close brackets, and then close brackets for the print. And then when I press play, so the distance sensor is actually scanning constantly when the program is running right now. But nothing is happening on the hub because I have told it to print onto the console. Okay, so I'm still scanning around, but in the console, if I open up the console down here, oh, whoops. It says none. Obviously, that this is only going to scan once because I didn't put a forever loop. Okay, so here we go while true for our forever loop. And then the line underneath, we tab it in, hit play again. All right, now it is reading the readings properly, okay? So sometimes it is showing a number for the number of centimeters, but sometimes it is showing none. Now, none means that it is not a reading that it can detect. Sometimes it's because the distance has maxed out or something is too close and then it doesn't detect the reading, okay? So here we have our distance sensor sensing something between the ranges of, say, about 20, 0 to about 40 centimeters. Okay, so there are lots of different modes for your distance sensor as well. So if I just stop this for a second, I can also go into my knowledge base to check out the distance sensor code. You can change the way that lights light up, and also what we are looking for here, get distance centimeters. There's also get distance inches and percentage as well, if you want to play with that. There's also a short range mode that is on default to false. And the short range mode basically makes it so that it is a little bit more accurate when it comes to shorter ranges. Okay, so that's how the distance sensor works. Well, what about if we want to do something like make the hub beep when I am closer than, say, 10 centimeters? Well, what I can do is I can go like this. While true, if oh no, I'll just go distance sensor dot wait for distance closer than, and then I'm going to go 10 centimeters, and you can see how this command works by looking at your distance sensor. You can look at wait for distance closer than, and then you scroll down, and then you'll be able to see all of the code examples here. Okay, so after we have waited for the distance to be closer than 10 centimeters, then what we'll do is we'll just make the hub beep. So hub.speaker.beep. Okay. So if I hit the play button, all right, so it is running. And then if I put my hand in front of the speaker, in front of the sensor, you'll hear that it's making a beep sound. See? So very, very simple to use the distance sensor. Wait for distance closer than, and also wait for distance farther than, followed by any code that you want. When it is waiting for the distance to be detected, it is literally stuck on that line, okay? So make sure that you have a way to actually utilize that code. Whoop, it starts beeping like crazy now, because I've just put put the thing in front. Okay, so here, very, very simple to use. We go, wait for the distance is closer than 10 centimeters, then the hub.speaker.beep. If I wanted to make it inches, then I would go comma and then put inches in quotation marks. Okay, so that's how to make it so that our distance sensor is triggering when something reaches a certain distance. All right. Let's comment this out and do our next sensor. Our next sensor in the tutorial is the force sensor. Now the force sensor is a little bit different to your EV3 touch sensor because it actually tracks a continuous reading from when it is just lightly pressed and when it is fully pressed. Okay, it actually tracks between 0 to 10 newtons, which is the amount of force that is applied to the force sensor, or you can track a percentage as well. Okay, like a force percentage. So when you're not touching it, 0%. When you're pushing it all the way in, that's 100%. We're going to do something really fun with this sensor as well. Go back to your code. We're going to comment out the... Oh, yes, we've already commented it out. Excuse me. We're going to now create our force sensor. We're going to attach our force sensor to port C. All right, here we are. Attached to port C. Now we got our force sensor attached. We're going to have to define it just like how we define all of our other objects. Okay, so here, force sensor. We'll go call it force underscore sensor in lowercase, separated by underscores. Force sensor equals force sensor at C. Now, we want to make it so that we do something interesting with our force sensor. How about we'll just do something simple first. So while true, we're going to make it so that we make a beep sound when we press the force sensor. Okay, so here we go, force underscore sensor dot, and then you can check out the knowledge base if you have any questions on what the pressed event is. So here you go, wait until pressed. Very similar to your scratch block. You go through here, wait until pressed, and then afterwards you do something. Okay, so force sensor dot wait until pressed, and then afterwards we'll go hub.speaker speaker dot beep. All right, let's try that out. Okay, so here's my sensor. Every time I press it, it makes a beep sound, okay? Super easy, right? But now let's take advantage of the continuous movement of the force sensor. We can make it so that our hub is responding depending on how hard we have pressed the force sensor. Now this bit is a little bit tricky, so make sure you copy the code exactly as it is, okay? So here, we're going to comment out the parts where we are doing the force sensor. Okay, so this is, yeah, it's pretty straightforward. I don't need to put any more notes in here. But let's go and make it so that our light, we're going to show a happy face on our hub, which actually we haven't really talked about here. You know how we showed the happy face on the hub? We can actually show lots of other different pictures as well. So here we're going to call it light matrix, and the method that we were using before was show image. If you click on the show image, you can see all the variety of stuff that you can actually put there. Yeah, you can see the variety of stuff that you can put here. So you can put in an angry face, you can put in a sad face, you can put in a heart small, heart big, put in the time, you can put arrows, butterflies, all that stuff. Okay, so we're going to make it so that when after we've defined the force sensor, we're going to say while true, hub dot light matrix dot show, and then we're going to put in a different, let's put in a duck. Now you're going to make sure that you spell your values exactly the same as it recommends inside the parameters in the knowledge base, because if it's not spelled exactly the same, it's not going to work. All right, I'm going to put a duck in there, but not only am I going to put a duck in there, if you look up at the start of this knowledge base entry for show image, the first entry is the image name, second parameter is the brightness value, and by default it is at 100, which is 100% brightness. So we're going to change that up. Instead of making it 100% brightness, we're going to make it to however hard we are pressing onto the force sensor. Okay, so we're going to make it so that it's force underscore sensor dot get underscore force underscore percentage, open close brackets. Okay, and that's going to make it so that if I press the force sensor harder, it's going to make the image brighter. Okay, let's test this out. All right, so there is an error. I'm just gonna have to have a look, see what the error is. Light matrix has no attribute show. Oh yes, show image. Oops. So if you have a look at my code here, you'll see that I have an error. It says attribute error, light matrix object has no attribute show. So when you get an error, you read from the bottom up. Okay, the bottom is the latest part of the code that has an error. And that's usually where you are going to find the cause of your error. So if it says line 100 and also up here it says line 1, you look at the lower one, so line 100, you look over up the top, we're at line 100, so line 100 is where the error is. It says light matrix object has no attribute show, and of course it doesn't, because the correct command is show underscore image. Okay, if I press play again, there is no longer going to be an error. So if I go into look at my table, there is no picture of a duck on this hub, but as soon as I press my force sensor, you can see it appear. So the harder I press it, the brighter the duck is going to appear. Yeah. So if I press it really lightly, the duck will only just barely show, but if I press it harder, the duck will show much brighter. Okay, very, very cool. I want to thank the sponsor of today's video, More Educational. Ever since Creator Academy started making LEGO education videos, we have been greatly supported by the experts at More Educational. They're an authorized partner of LEGO Education with over 20 years experience working with LEGO education products. So if you're in Australia and you want to buy genuine LEGO education products like the ones shown in this video, then make sure you check out the More Education website. Coming up next, we are going to be talking about the driving base, how to move a robot using Python. We're going to talk about motor pairs. We're going to talk about detecting obstacles. We're going to follow lines. We're going to move and manipulate objects. We're going to do multiple things at the same time, and also how to turn accurately. And finally, we'll do some more advanced techniques on how to use lists, functions, and checking out your errors as well. So I cannot wait to continue this Python tutorial. I will see you again next time. Bye-bye.